Fridays. This is a casual bi-weekly Friday showing from the team as well as the community, where we go through some casual demos. It's low production, no slides, just demo things and screen share if possible. The idea is to share what you guys did this week, how you made the robot better, but more importantly, talk about the hard things that you're still working through, what's not working, requests for help, feedback, and other inputs that you would like from each other and from the community. Hopefully everyone has something to share today, and I'm capping everybody at 2 to 3 minutes, so keep it concise. Cool, so the agenda is on the right. Let's start with Asimov team hardware. Do you guys want to go first?
Yes, thanks, Nicole. Let me share very quickly the screen here.
Do I need to stop screen sharing to allow Alex to do it?
Okay, I'm already sharing, Emre, so maybe you can switch. Yeah, so hello guys, this is just our GitHub repo for now. Still on private, but we will release it soon. I just wanted to show you guys that we basically have a lot of the mechanical ready and just how it's actually structured. So within the mechanical folder, you'll have the Asimov B1 folder. And inside here, you have a couple of folders that represent certain subsystems or subassemblies of the robot itself. So 100 is a torso, 200 is a pelvis, 300 is left arm, and so on, right? You guys have the naming convention here. The main file that basically is the whole robot in one step file, or individual, as I mentioned before. So for example, if we go within the torso, you have the torso assembly only, and you also have a fabrication folder, which is already all the parts required for that assembly divided within the manufacturing process that it should be actually made. So in this case, all the aluminum parts for the torso are here, right? And remember, we have a visualizer here. Once you click here, you can actually see the robot online and play around. But yeah, just wanted to show you guys that almost all this is completed. We just keep working on some little stuff on the manual and the bomb. So I'll pass to you, Ariel.
Oh, sorry, quick interjection. Alex, I don't know if you're ready to share the links so that the folks in the comments can directly access, or you can just let the community know if you want to share the links at a later time.
The links for the repo, the GitHub repo?
Yeah, correct. Yeah, if the links are in a shareable ready state, feel free to drop it in the comments so the community can actually click into it. And
I see. Yeah, I think we are not open sourcing the repo or making the repo public just yet. Maybe Amber can do an announcement on that later on. Ariel, can you share about the manual?
Yeah, sure. Let me share my screen. Yeah, can you see my screen?
Yes.
I'll just quickly go through the manual. So firstly, you can navigate the version here. By default, we set it to Asimov V1, which is the humanoid key we are working on. And also, I will introduce 4 sections here, maybe 5 sections actually. So before you start, and a quick start and overview, this includes what are the basic specs here and what is included in the DIY kit. So you have a basic idea if you buy it, what is included and what is not. For example, hands are not included and battery is not included. And before you start is some safety issues, some safety information and what you should do before what understanding you should build before successfully build the assembly. And quick start is a quick navigation about the whole structures of the manual. And after that, we have a hardware design where we introduce all of the details about the hardware, like mechanical part and electrical part and wiring. And also assembly manual is the main part for how you would assemble the robot. So you have a preparation section where you should it includes all the information about the tools you need to prepare, and also what is information and reading you need to do, and what is the extra safety tips you need to bear in mind, and also all these things that you need to keep in mind before assembly. And the assembly steps are the main steps for building the whole robot, and we separate it into separate modules, which you can navigate here. So it includes a pelvis and legs and arms and torso and head. And for each steps, we'll include what are the material list you need to do, including the mechanical parts and also the fasteners and electronics. And these are the graphs of the assembly steps. But we still have some details need to be corrected. So this is not like 100% there yet. And also after assembly, what tests you need to do to confirm that you assemble it correctly, like operations and homing, preparing for really operating the robot. And also before the locomotion policy deployment, you should check a few things. And after you deploy it, you should follow the steps to check one by one. And the locomotion control includes all of the learning we've done for sim to real and how to train the robot. And you better read this through to understand how to train your own robot. Though we will include a binary file for the locomotion policy, but still, if you want to do yourself, you should read this. And also Asimov API. I think Ishni later can give more detailed introduction about this. It's an API that we export for you to how to command the robot, and also how to control and also connect it to the medias, including like the cameras and also the speakers and everything. Yeah. And the BOM cost is just a list of all the materials. We need to update this a little bit more, so we will be working on this week. Yeah, that's all from my part. Who's next? Maybe.
Okay, it's electrical. But gentle reminder for team. I love that you guys are sharing what you shipped. Definitely also ship like what we're deciding was not working, requests for feedback, requests for help. It's meant to be very transparent sharing on the very difficult problems that we're working through. Oh, okay, just kidding. Quick question for hardware. Did you design the wrist and arm for a specific hand or a set of hands? So this question is from Freed. Thank you.
Yes, I can take that question. So far, the end of the robot, the coupling is meant to be used on Inspire hands. This is the hands that we just have laying around the office, and that's what we designed this way. But I mean, definitely we will support for more hands, and we can toss it over in the GitHub repo so you guys can either create your own and also please share, or we will just start updating once we have more time.
Sorry, my browser crashed a bit. Are the URDF files available today? URDF and step files. What is our ETA on that? Oh, Amre, maybe you can take this question.
I need to add myself to this.
I think Jason was trying to mention about this, but it seems like he has some problems with his microphone right now. Yeah, Emre, maybe if you share what's the plan to release the GitHub repo, and once actually that's released, the URDF files, well, not the URDF files, but like the XML file that we use for Mojoko will be there.
And I can quickly share. We are planning to open source it on Monday. Next week you will be seeing all of the files. Alex, you're ready.
Awesome. Yeah, hopefully that answers your question, Chen. Thank you. Mechanical open sourcing ETA this coming Monday. Keep an eye out. Okay, let's go to electrical. Jashan.
Yep, hello, can you guys hear me? Please select my screen, yep. So over the past 3 weeks, we've actually paused locomotion training because we've been having some really terrible hardware bugs at the board level. So I'd like to bring everyone through like what exactly was happening. So the way we communicate our motors is that our main CPU, and this is an 8-core chip CPU, communicates with our motors over SPI, which is then converted into CAN. So it's from CPU to the MCP 2515 over to a CAN transceiver and finally to the 6 actuators. And then we repeat this 5 times for the different limbs of the robot. Now, the problem we were having was that every time we communicated with the actuators, randomly, this data packet or this part of the data packet, the motor speed, would be corrupted. And it was consistently always happening at this one section of the packet. Now, for those of you who worked embedded systems before, this was very suspicious to us because if you count the number of bytes going on over here, you have 1 byte over here and 2 bytes over here. So it's always happening at the 4th byte in the packet. And something happening this consistently probably means that it's nothing to do with the routing of the thing, but something to do with the chip itself. Initially, we were really confused because hey, actually CAN is supposed to have a CRC mechanism. But the reality is that the CRC mechanism only happens at the CAN transceiver level. So what was happening was that after the MCP 2515 receives the data, it was flipping the data internally in the chip itself. Why this was happening, we never really found out why. I mean, to find out why will be a very, very deep dive, and it's not really the scope of what we're trying to achieve here. So what we did was that we swapped out for a newer iteration of the chip and used a faster crystal to communicate with it. And this resulted in the problem going away. But yeah, this was an insane problem. It took a really long time for us to debug this, and that's probably why you didn't see a lot of updates on socials from us during that time. Does anyone have any questions? I think the stream is a bit delayed, so I can answer questions during the next segment as well.
Awesome. Thank you for sharing the hard parts, Jashan. And for everybody, I think once you're done with your section, there are follow-up questions for you in the comments, but for the sake of time, I won't call out all of the questions. Okay, next up is firmware, edge software.
Yes, I can share my screen. So I'll play a couple of videos and I'll briefly explain what we did throughout the week as well. So the first video is where we just, after doing all the stabilizations as Jashan mentioned on the electronics, doing a bunch of changes on the policy side as well, we finally got SimToReal narrowed down to a very minimal level. So we are able to replicate at least what we see in Sim at the moment. The policy is not perfect. There's still a lot of optimizations to be done on the reward level, making sure the gate is actually proper. It's not, using it's using more of its heel of the foot to walk. And then so on, we were just doing a bit of stress testing. We removed the harnesses as well, just checking what are the edge cases, when it would fall, when it would stop. And then throughout this process, we realized that, there are a bunch of things we need to control. So battery power is very important for the robot as well. If the robot is low on battery, the motors don't track well and it doesn't walk well forward. So it's a lot of things you need to actually analyze its battery. You need to check if the IME is okay. So it's not just simulation, and it's more of like a very hardware software co-design problem. So this is what we worked on this week and made sure everything works through Asimov API. So you can send commands through the Asimov API to the firmware, receive telemetry back, as well as get video, audio from the robot as well to your browser. So you can do this. The guide we will be open sourcing on Monday. Yeah.
Thanks a lot, Isnit. Let me just quickly answer some questions, and the team that will present next have more time. So there was a question saying that if the robot in its current design was given form extension but no hands, could it be programmed to do cartwheel? I think you are trying to say like if it actually can drive a go-kart or something like that. If that's actually the correct assumption, I believe you should think it in a way that if you drive a car with your fist, like it will be holding, but you cannot move your wrist basically. So if that movement is actually possible, I believe the robot can also do it. And for the center of mass, yeah, it's pretty much same as a human, right? It's almost right in between the pelvis and the lower part of the torso. So that shouldn't be a problem. Okay, we can go with the next team.
No, I think he might have meant how would the robot do like a physical cartwheel, like the gymnast move, where you put your hands on the ground. Yeah, I don't know if that's possible, but we go.
Oh man, I thought I was trying to make the robot drive a go-kart. I mean, it's possible though. Like that's a metal part, it would just collide with it. It's like doing a wheel car with your fist.
Maybe someone in the community would tackle that cartwheel policy. We would love to feature that if and when you guys do. Okay, so moving over to software platform simulations. Yuki?
I can demo on the platform side. Let me
Okay,
share my
sounds good.
screen. Okay. Share screen. Okay, so can you see you guys see my screen now? So for our platform side, we are working on a semantic command set. So basically, instead of controlling the robot through low-level command like vx, vy, we are working on something that let user like send very high-level command like you walk forward for some distance, backward for some distance, and some angle, and for how long. So the user can basically go to our platform and get some API key and use their coding agent, any coding agent to control the robot. So on the left screen here is our platform UI. It's the simulation in our garage screen. I can remove it. So when I tell it to move forward like 1 meter like this, I'm controlling it through my coding agent in the terminal. It will send some command into this. Let's see. So you can see here on the right side, it will go forward 1 meter and stop. So I can tell it to turn 45 degree like this. So this semantic command is already on our dev rank and will be run out to user empty really soon. And also we are working on a thing like much more awesome, but for the sake of the the more we will provide a quick plan video to you guys like you can see here. We can control talk with the robot with our voice and we can perceive the environment. Okay, so the agent can talk back with you. Asimov.
Listen and speak. I'm here to help you with anything you need. What would you like to do?
Can you walk to the robot on the left side?
I'll head over to the robot on the left. I've started walking toward the robot on the left. I'll be there in just a moment.
Yeah, so this is a quick plan of what we have been working on and improving. So really excited to get this out as soon as possible. So you can test. Or how do I can stop sharing?
Awesome. Thank you so much, Tin. So Tin just previewed some very early previews, very early demo of the robot in agent mode, where you can drag and drop in your own agents and semantically command the robots on what to do. Cool. Anything else from the platform folks? Ashley, James, overall updates? By the way, guys, these are very polished demos. Community Fridays, it's meant to be casual demos, low production, and really let's emphasize the hard problems that we're working through, requests for help and feedback that we have for the community. That would be amazing, Jason. We would love that as well. Maybe if you can drop your Discord contact or some form of contact that you're comfortable with, we'd love to reach out after the call. All right, awesome. Hopping over to ops. Brand, anything from Mimi? Brand research, business updates. Okay, cool. I'll give a quick update on supply chain. Or Alex, maybe you want to give a quick update on supply chain?
Yes, sure. I don't have actually much to present, but let's just talk to it. So we've been reaching out to a couple of partners to help us actually build Asimov and being able to have all the parts ready for you guys to actually receive for those who already took some of the pre-orders on the robot. So once we actually open source everything, also the providers and our manufacturer partners will have access almost at the same time that basically the whole world will have. And from there, we will start working with them to actually start prototyping all the parts, do some quick quality checks on some of the assembly parts and everything, and then start to ship as fast as possible. So I believe that this is going to be a timeline within, I don't want to promise too much, but 3 to 4 months where like the manufacturer partners actually have time for them to develop its own robot and for us to do a quick assessment on the work. So you guys can have a perfectly working Asimov.
Awesome.
I'm not
Thank
sure
you,
if
Alex.
there's something you would like to think of. Yeah, I think that's
Yeah,
pretty much it.
just a request for help. If you guys have introductions into OEMs and ODMs, original equipment manufacturers and design manufacturers, we would love to onboard more partners. The ethos behind, I think, the Asimov supply chain part is we would really love a global supply chain so that your robots are made around the world. It's a bit more kind of regionally defensive, and if and when it breaks, it can be easily repaired by a local supplier within 12 hours instead of waiting for 2 months for a part to ship. Yeah, so if you're interested in supply chain partnering, I'm looking at the comments, or any other level of partnering across the entire stack that the team just shared, we would love your help, your input, and to onboard you as a partner. So Omre, do you want to take over this part? How can they become a partner? Where do they fill out a form?
Okay, we are preparing a couple of web pages for you to see the details on how you guys can partner with us on manufacturing. We will be sharing this probably in a few days, and just follow our social media channels to see the announcements, and we are going to share all of the updates. But in the meantime, if you guys are super keen to work with us, just visit asimov.inc and you'll be seeing Talk to Us button, and you can fill out the form and we will reach out to you and we will have a call to discuss the details.
Okay, I think that is all. Last but not least, before we go on to community showcases, if you guys wanted to join the channel and showcase your projects, even if it's a totally different company, we're very open to that. But before that, Herman, sorry to pick on you, do you want to just quickly share some of our open roles?
Sure, let me share my screen. Give me a second. Okay. Hi everyone, I'm Herman here. Nice to see all of you today. We've recently updated our career site and we're hiring a lot of roles right now. We're hiring in Ho Chi Minh City, we're hiring in Singapore, and even China as well. So we have many different roles. If you have anyone who you think might be a good fit, or even you yourself, do apply, and then we will look forward to chatting with you soon as well. Thank you.
I think that's all from our end this week. I think, Omri, do we want to open it up for community demos as well? Will they need a special link?
Yes,
to
they need to
join.
join the studio. They need to join the studio to share.
Okay.
Okay.
Okay. How do we best do that?
Yeah, if you guys send a message on Discord, I can invite you to the studio so you can share your screen and we can chat. We can have a chat. I just shared the Discord link in the general channel. I'm waiting for the new messages in general channel. Just message there and I will invite you to the studio.
Awesome. While we wait for that, there are a few more questions that we kind of skipped. Are we using the ROS framework?
Currently, we aren't using the ROS framework at all internally. We're very open to people making bindings for our API to ROS, but we didn't really see a need to use ROS internally in the robot development itself.
Awesome, thank you. They would like access to the BOM. Ariel, do we have an ETA on the BOM?
I think I can answer this question. So we still are like polish and correcting and update some mechanical parts and fasteners. But if you want a rough and hopefully we'll release it by today. But if you want a rough idea about the BOM, I think we have a like estimate overall price in the BOM list, like the body cost and like board and electronics and packaging. If you see the BOM list, and also if you want like detailed parts of like each module, you can also refer to assembly manual and assembly steps that you can see the corrected and updated mechanical parts and fasteners. Yeah, but we will like finalizing the BOM cost by today.
Awesome, thank you. We're also going to include prices in the BOM. So for folks who are self-sourcing, instead of getting one from, I guess, one of our supply chain partners, you'll see the costs, like the full low volume single MOQ cost. Where can we find documentation of how Menlo OS is architected? This is a good question for platform team. I don't think most of the platform team joined this stage. They're like in the audience. Okay. I will let you guys drop a link. Maybe. Actually, no, I have the answer to this. So if you guys go to docs.menlo.ai, the software architecture, quick starts, tutorial, guides are all there. For some reason, I cannot share links in the comments, so just docs.menlo.ai. How does money work at your company? That's a great question. How does this stay afloat? Where are things headed? So right now, Menlo is still bootstrapped. We are trying to do a lot without very much. There has been some interest, but I think for the time being, we're bootstrapped. This may or may not change in the near future. Where are things headed? That's a great question. Daniel, do you want to take this question? Are you in the stage? Okay, maybe for this part, I will leave you in suspense. So we have a big update on exactly these questions. How do we operate? Where are things headed in 2 weeks? So for our next Menlo Friday, maybe as an invitation to dial back for that one. Yeah, it'll come with a lot of very transparent community updates. The website will get updated among a lot of other things. Cool. I think those are all the questions. Do we have anybody from the community wanting to demo their projects, their company, share job openings at their company?
We only got one request from a community member, but he has not joined yet.
Nice. Can they just directly comment in the comment section and then we add them, or it has to be through Discord? I don't know if most of the
I just shared the
audience
studio link. I just shared the studio link with them, so anybody can join the live stream now. And let me paste the link one more time. If you guys click this link in the chat, you will be seeing the studio and you will be here.
Awesome. A question for the locomotion team. For the teleop, when is it going to be released? It would be great to have access to that. Ishneet, Salim?
I'll take this question. So right now we will plan on releasing the V1, so all the URDF files, the Asimov API for V1, and in the subsequent weeks, we will be staggering the releases, so it wouldn't be so like it wouldn't be very immediate because we need to make sure it's stable, it's safe to use before we release it as well.
Nice. So timeline ETA for that one. Sorry, haven't followed you guys much. Keen to know the domain where Asimov can be applied to. That's a great question. I'll say a quick thing, and maybe the team feel free to pipe in. Everyone has really great ideas on this front. It's meant to be general purpose. Asimov, in particular, if we're referring to the open source hardware, it's designed to be customizable. So we have some users telling us they're going to switch out the arms for Gundam wings, which is wonderful. That seems like a more personal entertainment use case. And we have some folks kind of looking at it for more industrial, commercial purposes. It's really designed to be quite customizable and repairable. And the AI inside is, of course, general purpose. Okay, cool. Maybe we can wrap up for this week if the community member isn't able to join. I'm not able to share, or I'm not able to see the backlog of who's on stage, so I'll hand it over.
Nobody has not joined. Yeah. Nobody has joined.
Okay, sounds good. Thanks for dialing in, everybody. And thanks for, I think, bearing with us as we figure out how to do these live streams. I think we're getting there. Yeah, thank you. Cool. We'll stick around maybe for 5 more minutes to answer more questions. And then for any additional questions, we can take it over to Discord. If someone can drop our Discord join link here. Okay, how much weight can the arms carry?
Give me a moment. I'm trying to recall right now. I think I did the math last time.
I might be misremembering.
Yeah.
I might be misremembering, Alejandro. I think last time you told me 30 carrying from squatting to standing. Is that still the case?
No. The arm itself, I think just on the elbow, right, to being able to lift it like this, I think it was like 10 kilos, something like that. I mean,
I remember last time you
course,
can hold the legs, which is 16 kg. So it can do this
Yeah,
and hold the
we
legs.
we actually have just the lower body that you guys have seen, which is B0, right? And we hold within B1 the legs on top of it, which is 16 kilo. So I believe that it's correct that each elbow can actually lift 10 kilo. I would need to double check, but yeah, it's around that.
Are you guys using foundational models for more general intelligence? Is it proprietary? Are you hosting already existing lightly fine-tuned versions of what's available in the market? That is a great question. So the whole Asimov plus software system, it actually has several models. For some of the models, especially models that add skills to Asimov, we use some open source models. And I think if you guys click on docs.menlo, you'll kind of see what that architecture looks like. For the core intelligence modules, they are our own. Yeah, so we'll be kind of sharing more on this shortly. The team has been kind of very heads down on this front. So maybe to give you an indication of what's coming, there'll be a lot more communications on the AI and software side in the upcoming weeks. Thank you, Martin. For people in Singapore, Machine Learning Singapore has a meetup next week. They always have really, really great speakers, and we're super grateful that I think they've given us a speaker slot next week. Another question, is the design modular to the point where I can extend the design to make a 6 feet tall version?
I mean, sure, you can actually make it as tall as you want. I will say that probably the only limitation will be the actuator's capability to actually lift the legs with that new mass, right? So we have over specs the legs for the size of Asimov. So in theory, yes, you can actually make it taller if you need it, but I'm not so sure if it can be that tall. Probably if you rearrange the weight or the distribution of how the motors are positioned to be a bit up instead of having to be all the way down to swing all that weight, definitely possible.
Are you planning to integrate any AI-specific compute like Jetson or anything else? Deshaun?
No, at its current stage, we're not planning to integrate the AI compute. So it'll ship with a Rexa CM5, which uses the RK3588. This is 8-core ARM CPU, as well as a Raspberry Pi 5. And it's mainly for networking, Wi-Fi, Bluetooth, and stuff. We didn't want to integrate a Jetson because we felt that the landscape for embedded AI compute is actually quite competitive. I think it'll be cheaper for users as well to source it in their destination country, rather than for us to source one, customize it, and ship it with them.
Yeah, and we also want to give you the option of having a very big brain in the cloud or on your local computer. Yeah, so for now, I think the design is assuming a remote big brain. Okay, I think that is it. Okay, thank you guys so much for joining. The TLDR is open sourcing mechanical is coming Monday. Stay tuned for other things like our approach for AI, more software updates. We will likely be taking a more agent-driven approach on that front. Yeah, and we'll see you guys in Discord for any remaining questions. Thank you again for taking the time, and thank you, team, for presenting.